Hello friends, today we are discussing on the topic is base condition and stack overflow. So let's talk on a stack overflow. So in software, a stack overflow occurs in the call stack pointer. Exceeds the stack bond. The call stack bond may consist of a limited amount of address space, often determined at the start of the program. The size of the consists of limited amount of address space, often determined at the start of the program. The size of the call stack depends on many factors, including the programming languages, machine architecture, multi-threading, and the amount of available memory. When a program attempts to use more spaces than is available on the call stack, that is the when it attempts to access memory beyond the call stack's beyond, which is essentially a buffer overflow. So, in stack is set to overflow, typically resulting in a program crash. So, causes infinite recursion. So, the most common cause of stack overflow is excessively deep or infinite recursive, in which a function calls itself so many times that the space needed to store the variables and information associated with each call is more than can fit on the stack. An example of infinite recursion is Java. So static void main and then return function. The function when it is an invoke continues to invoke itself, allocating additional spaces on the stack each time until the stack overflows resulting in a segmentation fault. However, some compilers implement tail call optimization, allowing the infinite recursion of a specific sort. Tail recursion to occur without stack overflow. It works because tail recursion calls do not take up additional stack spaces. Some Java options will effectively enable tail call optimization. For example, compilation the above simple program in .java with 01 will result in a segmentation fault, but not when using -2 or -3. Since these optimization levels imply the for optimization sibling calls. Compiler options. Other languages such as Scheme requires all implementation to include tail recursion as part of the language standard. Very deep recursion. So a recursive function that terminates in the theory but was a call stack buffer overflow in a practice can be fixed by transforming the recursion into a full loop and storing the function arguments in a explicit stack rather than its implicit use of the call stack. This is a way possible because the class of primitive recursive function is equivalent to the class of loop. Computable functions consider this example in Java. Thank you.